Welcome everyone to this first episode of Mastering Foundry, where we will install Foundry, deploy a smart contract local, deploy it on the scroll, testnet, and verify the contract, and actually interact with it as well. Major shout out to Cyfrin Updraft. This is a summary version of my study session this morning where I will showcase everything that I learned. Let's dive into it. I've written an article, by the way, so if you prefer a written format, I will leave a link in the description down below, and it has all the terminal commands. And I also have a GitHub repository where an example of the code that I deployed is there with a transaction hash and the verified contract link. The first thing I'm going to do is open my code editor. Installing Foundry is very easy. You take this command, this curl command, paste it in your terminal, and press enter. I've already installed it, but if you're on a Mac just like me, you'll be requested to set the path right. It has the command over here. You copy paste it and then run Foundry up. As soon as you run Foundry up, it downloads the latest version and installs it. Awesome. We have Foundry installed. The first thing I'm going to do is do forge init, and this creates a standard Foundry repository. Inside the source folder, this is where our contract lives, a smart contract. I'm going to replace this one with an example contract from Solidity by Example. This smart contract called Ether Wallet. Copy it, go back, paste it, and then I'm going to change the name of the contract to Ether Wallet, save it. Next, what I'm going to do is I'm going to remove the test file because we won't be covering that in this video. After we have our contract, I'm going to go ahead and type forge compile. This compiles a contract. Cool. In the out directory, head over to Ether Wallet, and over here you can see the ABI file. I haven't formatted it, but you can install a formatter that formats the JSON file nicely. An ABI is the application binary interface, and it contains all the functions, variables, and data types inside my smart contract. Time to deploy this smart contract locally. The first thing that I'm going to do is run the command Anvil. Anvil runs a local blockchain on your computer. Now, if you want, you can import Anvil into MetaMask and the accounts that are available to you by Anvil over here by importing the private keys. But since we will be deploying through the forge command CLI, I won't be doing that. So let's go ahead and deploy a smart contract by using a simple command line, forge create, and with your contract name, and then -- RPC URL, the server address of your local blockchain, -- interactive. Copy this, open a new terminal. I'm going to go ahead and paste it. Now I've got an error, and that's because if I go back to my Anvil, you can see it over here that the port is actually 8545. So I need to change the port, run it again. I need to enter a private key, go back to my Anvil blockchain, and over here I've got a bunch of private keys that are available. Copy this, paste it, and there you go. I deployed my smart contract. Step 1 cleared. Now, when you pass your private keys through the terminal, you don't want your terminal to keep a history of all the times you've passed your private keys. So what you can do is type history-c, and this deletes the history of your terminal. Now, if I press up, you can see the last command was clear, but before that, I can't rerun my commands. So this is a nifty trick for you to prevent your private keys being exposed. Now, another way you can deploy your smart contract is through forge scripts. Scripts is just like any other dev tool in Hardhat or Ape, where you run a script, and Foundry in this case will pick up the smart contract, its API, and deploy it to any blockchain that you might choose. In this case, we're going to deploy local again on Anvil. So over here, you can see a simple script. What we're doing is we're importing the Ether wallet from our etherwallet.sol. The most important part is that we initiate a new Ether wallet and tell Foundry to deploy it. Now, if you want to go into more detail on how this script exactly works, Cyfrin Updraft has a great lecture on this. But like most dev tools, this is a boilerplate script that works slightly different if you're passing arguments. But my constructor in my smart contract doesn't take any arguments. So I can go ahead and copy this, paste this, save it. And then I can run a command that says forge script deploy Ether wallet. So I'm going to copy this. I'm going to paste it here. I'm not going to run it yet because over here you can see I need to rename my file. So I'm going to go ahead and rename it to deploy ether wallet.s.sol. And the .s extension basically means that this is a script written in Solidity. Now that I've renamed my file, I'm going to go ahead and copy this command, paste it over here, and then use the forge script to deploy my smart contract. But before I do that, I need to pass my private keys. I'm going to go back to Anvil, select my private key for one of the accounts, paste it over here, hit enter, it compiles, and deploy the smart contract. Now over here, you can see it created a broadcast directory. What you can see in here is all the transactions that were associated with your latest deployment. So in this case, I run the Ether wallet script, and you can see over here what type of transaction it was, which address it was sent from, the amount of gas, nonce, and a bunch of other data. I won't be covering what a transaction structure looks like, but Cyfrin does an amazing job of going in depth and explaining exactly what you see over here and how you can use the data. Now that we have deployed locally, let's start deploying to a actual live testnet scroll Sepolia. The first thing that we'll need to do is create a .env file. Now, this is a great method to store private keys and RPC URLs and a bunch of other environment variables, but it's not meant for production grade. In order to develop for a production environment, you need to encrypt your private keys properly. Foundry doesn't support that natively yet, but hopefully it will in the future. Let's go ahead and create our env file, open it up. I'm going to come over here and copy these environment variables. I'm going to paste them in here. Now I'm going to go off screen and paste my private key over here. You never ever want to expose your private keys. As someone who has access to your private keys has access to all your funds and can take ownership of your smart contract. Once you've saved your private keys to your .env, you need to load your .env so Foundry can actually use it. Go ahead and type source.env, and this loads the env file for Foundry. Next, what we will do is run the following command, which is basically deploying the script, but now instead of passing a local host for our RPC URL, the local Anvil, we'll pass the RPC URL, which contains the RPC endpoint for scroll network, and we'll pass the private keys environment variable from our .env. I'm going to go ahead and copy this, paste it here, and deploy it. Now, this might take a little bit longer as we're deploying to an actual live testnet. We've successfully deployed the contract. We can go ahead and look it up on scroll Etherscan. And over here, you can see 20 seconds ago, we deployed this smart contract. Next up, we're going to verify our contract. Verifying a contract enables someone to actually see the contract, interact with it through the scroll Sepolia Etherscan. Now, what you need for this is an API key and a verify URL. Like I mentioned, any form of key you don't want to expose. So what I'm going to go is go off screen again, add these environment variables to my .env, and then we'll come back. If you don't have API keys, you can go ahead and register an account on scroll Sepolia Etherscan. And once you're registered inside your portal, you'll be able to navigate to API keys and copy and paste your API key inside your .env. Once you've updated your env file, run source.env again, so it reloads the environment variables. Next, we can use the following command to let Foundry verify our contract on Sepolia Etherscan. Go ahead and copy this. I'll paste it in my terminal. Now I need to replace the contract name with my contract name, which is Ether Wallet, and I need to pass the contract address, which I can get from Etherscan, copy it here, paste it, and then I can go ahead and run this command, and it starts verifying. This one is already verified, so it skipped it, and we can double check that by looking at the green check mark. In this case, over here you can see the code, which is in a readable format. If it wouldn't be verified, you'd just see a bunch of byte code over here. Awesome, we've deployed our contract on a live testnet. Let's start interacting with it. I deployed an Ether wallet that is able to receive any Ether, and the owner is able to withdraw the Ether. So first, let's send some Ether to this smart contract. Over here, I've got an example where I'll need to replace the smart contract. So I'll copy this, paste it over here, and then I'll replace the smart contract address. Notice I'm passing a large number, and this is because the denomination is in Wei. The base denomination in EVM or EVM-based chains is Wei, and so 1 ETH equals 1 and then 18 zeros of Wei and 9 on top of my head with Gwei. And this has everything to do with the fact that an EVM doesn't actually process decimals, so it uses big numberish. If you're more interested in that, I'll also leave a link in the description down below explaining how big numbers work on Ethereum or EVM-based blockchains. So in this case, I'm only passing 0.01 ETH. I'm going to go ahead and press enter. Awesome, my transaction went through. If I go back to Etherscan, go to transactions, I refresh the page. Over here you can see I've sent 0.1, not 0.01 ETH. Cool. Now I can see the balance over here. Let's query the balance inside our terminal. So what I can do is go over to this terminal, go over to this command where I use a call function, pass the contract address, and then call the function getBalance. This function you can find inside my smart contract. If I scroll down over here. So you can use the cast command with the call keyword to call any function that retrieves data. I'm going to copy the command, paste it in my terminal, and I need to replace the contract address. I'm going to go hit and enter, and over here you can see I get a value return. Now the value is returned in hex value. I can convert this value into a normal value using the cast to base hex value and then decimal. So if I go ahead, copy this, run it in my terminal, grab the hex value, and type decimal. Over here you can see the actual Wei notation, which is the same that we passed over here. Since I'm the owner of this smart contract, I would like to withdraw the ETH that is locked up in this smart contract. I can go ahead and do that by calling the withdraw function. So over here we have a function called withdraw, and only the owner of this smart contract can actually call this function. I'm going to go ahead and copy this, paste it in my terminal. I'm going to go ahead and send this transaction. Awesome, that went through. We can go back to Etherscan. So over here you can see balance 0.1 ETH. I haven't refreshed it yet. Refresh the screen, and over here you can see 10 Wei, which basically most of it is withdrawn. And 30 seconds ago, you can see I ran the withdraw function. And there you have it. We installed Foundry, run Anvil as a local blockchain network, deployed a smart contract on it, deployed it on the scroll testnet, verified it on the scroll testnet, and then we also interacted it through Forge Foundry CLI. Honestly, I skipped over quite a bit when it comes to the nitty-gritty details of learning Foundry that I actually learned this morning going through Cyfrin Updraft. Major shout out to Cyfrin Updraft, but this is just a quick summary. If you want to install Foundry, deploy, and get running. Highly recommend going through the course of Cyfrin Updraft. I'll leave a link in the description down below if you want to check that out. See you guys in the next episode.